everyone, welcome to Duodecimal Division. My name is Eric Larson and this is the 6th video in a series of videos that I'm calling The Secrets of the Numerals. The reason I'm calling it that is what I'm doing is sharing with you what all the hidden geometric information is, or the base 12 geometric hidden information is within the various numerals. So in this video we're going to go to the 6th circle in this series of circles, and we're going to find out why the numeral that represents the number 6 has the shape that it does. So the 6th circle in the series is the circle with the radius of the square root of 6, and that particular circle is similar to the 3 in that it doesn't actually land or intersect on any lattice points. So what we're going to do is use this pattern on the inside here to find out where there is a spot that we can actually go to define that square root of 6 radius circle. So we're going to go to the 3rd circle again, which is the radius of the square root of 3. Going to make a point where that one is on the y-axis. We're going to just go over and make 2 more points on either side. So those are all in a straight line. All those points are generated from this original pattern, and we're just going to draw a line connecting them like that. Then we're going to do the same thing over here. We're going to go to the square root of 3 radius circle and then the points above and below it, and we're going to draw a line through them, and that gives us this point right here. So when we apply the Pythagorean theorem of going over square root of 3 and then up the square root of 3, square root of 3 squared is 3, and same again, 3 plus 3 is 6. So that gives us the point that's exactly the square root of 6 from the center. So now what we're going to do is go to a point that's very close to that one, just outside. This actually is a lattice point. It's going to be a point that lies on this line here that's in units of square root of 2. So we're going to go over 1.9 and up 1.9. So the coordinate points of that point there are negative 1.9 and 1.9. And again, this is all in base 12. So we're going to start doing some base 12 math now. So what we want to do is figure out just how far outside, or what's the length of that line, how far or how close is that point to the actual square root of 3 radius circle. So that length there, therefore, is 1.9 root 2. Let's write that first, 1.9 root 2. So 1.9 squared is 3.09. So the square root of 3.09 multiplied by the square root of 2 results in the square root of 6.16. That's right there. 6.1 square root of 6.16. So that's the length of this line right here. So now we've got the point that is the square root of 6, and then we've got the point that's just outside of that square root of 6.16. So I'm going to actually draw it now, or trace the circle with the radius of the square root of 6. Because that's definitely part of the pattern, or the numeral. We know that it has a complete circle as part of its design. There we go, and I'll just rub out this little bit of line here. Okay, so we'll leave that as kind of an X marks the spot. So now what we'll do is, what I'm going to do is draw a line going off of this coordinate point here at a 45-degree angle going up that way. So what I'm going to do next is just mark off all the points on that line. All the way up to there. So the coordinates of this point here is 2.6, and then the y coordinate is 1, 2, 3, 4, 5 is 6. So now I'm going to basically connect all those dots. And there we go. That's why the numeral 6 looks the way that it does. And one very interesting aspect to that particular line is the fact that it's going through all these line segments here, these little, sections of 1. It's going right through the center. And so again, we're in base 12, so half of 1 is 0.6 in base 12. So we got the decimal value of 6 incorporated within that line and incorporated within the symbol. So again, I'll start writing this down here. We've got the length of 6, and we have the decimal value of the length of 6. We also have the length from here to there is the length of the square root of 6.16, and then 2.6 squared is 6.3. So I'll just write that down here. 2.6 squared equals 6.3. So 2.6 equals the square root of 6.3. And that's where, if you draw a straight line going down here, we come to this point right there. Just again, outside of the square root of 6 radius circle. So the next thing that we want to do is figure out the length of that actual line there, or what's the actual length of the line. So we have a right angle triangle in there. So I'm just going to draw a little dotted line over here, put that symbol there, and the length of these two lines is 1, 2, 3, 4.3. So I'm just going to write that, well, I'll write that here, 4.3, and this is also 4.3. So 4.3 squared equals 16.09. So the square root of 16.09. Now basically that's this line here. So I'm going to multiply that by the square root of 2. So that length of that line is 4.3 root 2. So 4.3 squared, 1609. This results in the length of this line being 2 times 16.09, which is 30.16. So that length there is the square root of 30.16. So we kind of know in base 12 that 6 squared equals 30. So therefore 6 equals the square root of 30. So the length of that line, if it was exactly 6, would be the square root of 30. But we see it's actually a little bit longer, the square root of 30.16. So I did a little bit of calculating, and I discovered that the actual square root of 30.16, or very close to it, is 6.016. So basically 6.016 squared equals, I'll write it down here, sorry, not the square root, 6.016 is 30.0, or 30 point, sorry, just get my calculations right here. 6.016 squared is 30.16023. So actually, I was going to write that down here. That yeah, 6.016 squared equals 30.16023. So 6.016 is the square root of 30.16023. So that's the length, basically the length of this line. Again, 30.16, which equals 6.016. So how long is that compared to that actual line? Well, if we start here at 1, 2, 3, 4, 5, 6. So we're at 6, then 0.01. So 0.0 means that the length is in that first little square just below that line, the x-axis. And then 0.1 means if we divide that line, that little section into 12ths, it's one of those plus a tiny little bit more. So basically just almost the thickness of that line there in pen. The pen line is about the thickness of 0.016. So very close to the actual length of 6 is what we're looking for that particular line there. So that's why the numeral 6 looks the way that it does. You can see all the different 6s in there. We've got the height of 6, And something else actually, look at the decimal value, but I was looking at this, and here this coordinate point 2.6 and 6, for the 3 on this side we have the coordinates of 1.3 and 3. So the 3 was demarcated or had the line at 3. This one has the line at 6. It's kind of an interesting relationship between the 3 and the 6, or in the square root of 3, square root of 6. They both don't land on lattice points. Again, there's a certain relationship between those two symbols. That's why the 6 looks like the way it does. I'm going to put the whiteboard behind so you can see that. Okay, so I think I've got all the different values in there written out. Yeah, that's why the numeral 6 has the shape that it does. So hope you enjoyed that. Now we're going to go to the 7th circle in the series, the square root radius of 7, or the square root of 7 radius, and we'll see why that particular numeral has the shape that it does. So hope you can join me for that. Thanks for watching.